with today's session.
Thank you so much, Emma. I'm just going to do the sharing screen dance. Where did my screen go? And there we go. So you should be able to, and Emma, if I drop connectivity at any time, just give me a shout. You should be able to see my screen. This is a very interesting session. I don't think you understand how interesting, because I'm a Java advocate going to speak on .NET apps. And the reason for this is that I have been speaking on Azure Spring Cloud for Java developers for the last year. And we recently announced Steeltoe, and Steeltoe, if you don't know it, is a .NET framework, and it's come to Azure Spring Cloud. And suddenly now I'm getting to speak with all of these .NET, these communities and these customers, and we are now collaborating with the .NET team to do this. And I am doing a collaboration with Shane Boy. If you don't know him, he's a principal cloud advocate for .NET, and we're franchising this talk. Both of us are doing a little bit of Java, a little bit of .NET across the world here, because it's a great time to be a cloud developer when you've got a framework that can actually cater for microservices across any language. And it's kind of the backstory to this technology. A lot of times you get to a customer, you get to a company, and they say, yo, we've got a .NET team and a Java team, and they run on separate systems, on separate servers and separate clouds, and then you say, but why can't they do it together? And you go, no, we don't have a framework to do it together. And in steps Steeltoe, which is their framework. And I'm going to go through this in the session today. I'm going to go through the mechanisms of it, some of the architecture. I'm going to do a demo, then I'm going to give you some homework. And the homework is a quick start that we prepared, that I've helped with the Azure product team. It's very simple, it's very engaging. I'm going to show you how to get started with this, and you can start on your journey on how to interoperate between your Java and your .NET clouds. Okay, so let's set this backstory here. So what is the business proposal that I want to give you? And I want to role play a little bit here, that I'm a microservice developer manager, and I'm looking for a solution for my product team to drive, and I'm investigating all of these alternative solutions. So my business is growing and the technology is evolving. I've also got distributed teams, and they're changing rapidly, especially in this COVID climate. And companies like myself are looking to become more agile so they can innovate and respond to change faster. In my large distributed project, I need to let each team independently build, verify, deploy, and monitor their services. I also need my applications to scale quickly to potentially millions of users across the globe. I need independent services that can be scaled based on their respective demands. And I also need to work more efficiently through an end-to-end development experience, coding, debugging, and deployment, and monitoring and management with integrated tools and DevOps. Then I'm going to have a chance, once I have that, with my booming business, to achieve reliability and faster time to market. So I do this also with microservices. And if you don't know microservices, they're a software architecture style in which applications are composed of small independent modules that communicate with each other using well-defined API contracts. Each service is a highly decoupled building block that is small enough to implement a single bit of functionality. Now, your typical microservice project consists of a collection of many of these services. Besides for the services themselves, let's discuss the other components that appear in a typical microservice project. So my services, they need management and orchestration components. I don't want to have to manage them the lifecycle myself. These components are responsible for placing services on nodes, identifying failures, and rebalancing services across the nodes. Also in this diagram, we have some microservices which expose external APIs to customers and clients. In real-world systems, this number can grow very quickly, as well as the entire system's complexity. I'm going to need a much better approach, and I'm going to use an API gateway. So now that I know that I need microservices, I also want to use Azure because it has data centers across the globe. Now I have a plan. To meet my needs, I'm going to first, one, build a cloud native microservice so it understands it lives in the cloud. And then two, leverage off the global data center footprint. Part one seems difficult. I have dozens of microservices, so I'm going to show you how to design them for the cloud. So the first thing is I'm going to choose Spring Cloud as my framework. Now I know what you're thinking. The word Spring implies Java, but in this case, Spring Cloud is just the actual platform that we're going to choose because Spring Cloud also runs .NET, the title of this topic. So we're going to use Spring Cloud as your framework, as my framework, and Spring Cloud provides 4 key modules necessary for our microservices. First, the Spring Cloud Gateway provides a simple yet effective way to route our APIs. Spring Cloud Service Registry allows automatic detection of network locations for service instances. And you will know the Service Registry by a very common name, Eureka, and that's the Netflix package of software that really makes it easy to find the service. If you've got many services, it registers and you can discover your services. With a config server, you have a central place to manage your external properties for your applications. And finally, Spring Cloud monitoring and tracing via Sleuth can easily be by providing distributed tracing. Next, let's see how we can interact with our backend applications and handle connecting to the many different Azure backend services that support our microservices. Now, instead of owning the backend service, you simply consume it. I want to use them and make my code portable. Now, we can achieve this by using Steeltoe.NET Azure Libraries. Now, these are open source libraries backed by both VMware and Microsoft that further simplify connection and consumption of Azure managed backend services. Think of them as kind of obfuscating away the need to understand the protocols to interact with your services. They give developers a Azure Spring Cloud idiomatic way to connect and consume Azure services with only a few lines of configuration and minimal code changes. And we'll look at some of them when we do the demo on how you can get started with these libraries. So we've already introduced the concept of orchestration and management. Typically, this component is off-the-shelf technologies such as Kubernetes, and I'm doing the correct pronunciation. If you don't know Kubernetes, it actually is Greek for helmsman, and you take your containers, you pop them into this orchestration layer, and then it juggles them for you. And Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. It has many of the features I'm looking for to orchestrate my microservices. So as you can see from this diagram, this is a typical workflow on how Kubernetes rollouts work. But it seems I have to learn a lot of things like pod, scheduler, YAML, and how to operate them. Let's try and find an easier way, as I only really want to focus on managing my business apps. What I'm really looking for is an approach to easily operate and manage the infrastructure, the cloud components, and the .NET applications on hundreds of instances. It sounds actually quite harder than what I'm thinking. My main goal then is to set up and host a Kubernetes cluster, build and host a cloud registry config server and distributed tracing, and containerize my .NET applications, deploy them to the Kubernetes cluster, and wire the applications up with the cloud components. Then perform start, stop, scaling, and other applications to manage the application's lifecycle. And this is really the point of this presentation, because there is a platform, and we've just released it last month, called Azure Spring Cloud that actually might be what I'm looking for. So Azure Spring Cloud removes the burden and related challenges of setting up and managing the Spring Cloud components and Kubernetes. It's a fully managed service for Steeltoe.NET applications and Java applications. It lets me focus on building the applications that run my business without the hassle of managing the infrastructure. Now I've got dozens of microservices. I can automate resource management and application development using my DevOps tools. Now I've got a big team. I can monitor the health of these applications and isolate failures to some microservices using Azure Monitor and achieve authentication using Azure Active Directory. Azure Spring Cloud with Steeltoe is integrated into the Azure ecosystem, and it really is focused on enterprise-ready applications. I've also noticed that I must deploy my applications. After deploying them, if I deploy them to the Azure Spring Cloud Steeltoe registry, my applications are automatically wired up with the Spring Cloud config server and service registry. Some applications can interact with any of the Azure or external services. And you will love this one. Now, as a developer, I hate debugging, and it's very difficult to understand how microservices work. Now, with out-of-the-box support for Azure Monitor, I can easily visualize how applications are performing, and I can isolate potential problems to individual services. I can also set alert rules for some important conditions and identify and address issues before end users notice them. So a little bit more about Azure Steeltoe. It's in public preview right now. You can sign up for it and you can start using it right now. And you've got a full features of Azure Spring Cloud. So you've got the app lifecycle management, integration with Azure monitoring. You can run Java and .NET apps side by side and get them to interoperate and speak to each other using the same registry and cloud services. Zero code changes, .NET Core 3.1 and above. And it's powered by Steeltoe, and Steeltoe really is an old framework that leverages Netflix OSS, Spring Cloud, and other industry-leading services to give you a microservice framework that is really focused to take the power of .NET Core and then place it in the cloud. It's also got Visual Studio support to publish Steeltoe.NET apps to Azure Spring Cloud, and that's coming soon. So sign up for it. It's in public preview. And this is what it looks like. So imagine my teams. I've got my distributed teams there, my Java team, my .NET Core team, and I've got some microservices there. And I can get a view of the distributed tracing of my apps, of my lifecycle. I can integrate with DevOps, all in one integrated portal. So in this summary here, I think I found the platform that I was role playing to supercharge my .NET apps and deliver features to the market faster. It's going to let me focus on the application iteration and debugging and let the platform manage all the other responsibilities. It's a managed service for Kubernetes. So you've got Kubernetes, and on top of that, VMware and Microsoft has supercharged your Kubernetes to allow you to just focus on the application iteration and debugging. So we've made some great time, actually. I might even be ahead of time. So I've got some a demo and some homework that we're going to do that you're going to get started on now. And this is the demo and the homework. So in here, and let's discuss this, we've got our GitHub repo, and that has our weather data. So our GitHub repo really has a config file that feeds into the config server, and it has some hard-coded weather data for planets. Mars, Venus, Mercury, and I think Jupiter or Saturn. And that replicates really or simulates a database into the config server. And the config server is pushing it into the planet weather provider, our first microservice. The planet weather provider then is called by the solar system weather microservice to get all of the planet's weather in one call. And returns the JSON for those 4 planets. Both of those actually are registered in our Eureka server, which runs on Azure Spring Cloud. And the client for this quick start, we're going to use a browser as a client, and you can access this microservice, this sample app. It's available on cda.ms/1mh. So it's a quick, easy URL to use. It's part of our quick start portal. So I'm going to share my screen here. I'm going to just minimize there we go. So it's part of our quick start portal here. So if I go let's go Azure Spring Cloud quick start, I'll show you exactly what we're going to do. If I do a little bit slow typing, understand this is my 4th month using a Mac. I'm getting better. And if you followed my progress, you'll know that I'm getting way better. So you can see here on the quick starts, and look how brilliant this is. On the quick starts, we've got Azure Spring Cloud. Now we've got a pivot here on Java and C#. So you can do the exact same kind of examples in Java and C# and deploy them to the same Spring Cloud. We're going to focus on Spring Cloud, C# here. You can do a hello world, and you can also do introduction to the sample apps. You get all of the demo here, and you can even see that the diagram is that I took here. This is the kind of system that we're going to show right now. So that's the homework that I'm going to give you, and with the URL that we're going to do. So let's look at what I did to start with. Now the first thing I'm going to do is I created my Azure Spring Cloud. So let's go and create another one. I've already got one running the demo here. It takes about 15 minutes to create everything in the demo. So I'm not going to do that live right now. I'm just going to show you how I did that. Now I've got my subscription. I've got my resource group. We'll create a new one here. We'll call this Reactor RPZA after my initials and the beautiful country I live in, South Africa. The service name here, we can call this Reactor RPZA. I'm going to use US West 2. And now you get a choice between 2 different pricings. Now you can choose the standard pricing, and that's that price per month. So it's $1,000 per month. But what you get is you get 16 CPUs and 32 gigs RAM. So this standard pricing is actually the same pricing as app services for a P2 app service with the same kind of resourcing. It's incredibly powerful. You can get drunk off the power. You can create 500 microservices with this standard price. But if you don't want to do that, you can use the basic tier, and it's basically the same price as your entry-level app services. And then you get a little bit less CPUs, and you also don't get an SLA, SSL, VNet integration, and blue-green deployment. So I'm going to choose here standard pricing, and I'm going to choose select, and then diagnostics. I'm going to activate log analytics. I'm going to do activate tracing. I'm not going to do a VNet, and then review and create, and I'm going to create it. And that's how you actually go in and create your Azure Spring Cloud. So we're going to wait for this to finish. And while that is validating, I'm going to show you Steeltoe, pardon, Steeltoe OS. There we go. I just wanted to show you, let's just go create there, the Steeltoe portal of for all the libraries. So this is steeltoe.io. This is the libraries that we're going to use in our application, and you can go into there's quite a lot of nice samples here, and you can go through all of these, and all of these work on our Azure Spring Cloud though, and you can go into learn, getting started. There's so many different nice examples here that you can play around with this. And it's very well maintained, so that's great. So that's Steeltoe and some of the libraries. So the sample that we're going to do, and I've already cloned it, is available also the completed example on the Azure Spring Cloud samples. Let me make that a little bit bigger. Azure Spring Cloud samples. You can see here's my GitHub, and I've even got code spaces. If you haven't seen my code spaces session, I've actually got a code spaces session on this that I've been running extensively. Let's go through the project. It's a .NET project, so you've got your SLN file there, and then I've got a config location, and the config location just has my planet weather provider, so it'll give you the weather for Mercury, Venus, Earth, Mars, and it simulates a database, Jupiter and Saturn. And then I've got my solar system weather, which is just it's the same entry there, just to give you the data for those planets. Then I've got my source folder. Now the source folder is really what we're looking for. And I've got my 2 microservices, my planet weather provider and my solar system provider. And I've deployed those onto our Spring Cloud. and the exact same system that we used before. And I've deployed those and I've created those apps. And I've got my two apps here, my Planet Weather Provider and my Solar System Weather Provider. And you can see there .NET Core 3.1. I've also shown you that I can interoperate with the Java 8 app on the same instance. And if I go into that, it just says hello world, but it's running on the same instance and actually deploying to the Eureka server at the same time. I need to make that a little bit bigger. Okay, I'm not too sure why that's not going bigger. Let's go bigger. There we go. Greetings from Azure Spring Cloud in Java. Okay, but we're here to do a .NET session. Now I've set up the Planet Weather Provider, and I'm going to show you how to deploy that also, and then the Solar System Weather Provider. And you've got a lot of other configuration options here. You can see there, if I wanted to go down to up to a higher pricing tier, we do support going from basic to standard, but not from standard to basic. You also got, and we're going to go through that, alerts, metrics, diagnostic settings. Now I've switched on diagnostic settings already on my my cloud. It just basically means that I want to log everything. So you can see there, I've got my log analytics workspace, and I've just said just log everything. We're going to go in there later. We're going to play around with the logs there to see how you can see there. I've got logging everything. How the logs look like and how the distributed tracing works in. So this is my system here. Let's go into the actual code and see what we're doing. And the first thing that we're going to look at is the Planet Weather Provider in code. And you can see there that the Planet Weather Provider doesn't have a microservice endpoint because it's actually being called by our other microservice. So I've got my .NET Visual Studio Code Insiders Edition here. Let's make that bigger. And I've got my GitHub repo that I've already cloned there, my Planet Weather Provider, my Solar System Weather Provider. And if you want to run this locally, you just have to set up a Eureka registry, and you can run it locally. We're not going to run it locally because I've got Azure Spring Cloud. So in my Planet Weather Provider, the first microservice, you can see it's a .NET application. I've got my startup.cs, and let's go through that there because this is the middleware that we're going to set up our configuration. So I've got my configuration, I've added my logging, and I've added my discovery client, which is my Eureka client, my distributed tracing, my Zipkin exporter, which is my distributed tracing also, and then my controllers. And now these are all, if you see here, using Steeltoe discovery client and tracing. And the Steeltoe libraries are by the Steeltoe company. So we're not only using Microsoft libraries for .NET, ASP.NET Core, but also the Steeltoe, sorry about that, the Steeltoe libraries. So we've set it up in our configure services, and then we want to configure our actual application. So we can choose is development, and then you can use the development exception page. And then I use the discovery client, add routing, add my endpoints for my controllers, and then use the tracing exporter. So I really only had, with the Planet Provider, one controller, the weather forecast controller. So I've got my weather forecast controller, extends controller base, and then I've got my configuration config, and the config really gets the config from the weather config, which is loaded in via the config server. Let's go get that. Sorry there for a second. Yeah, so that actually gets injected from the config there, and then I can just choose the index. So index 1, Mars, Venus, and then I can go getting weather for planet, and it will return the planet that I'm getting. And you notice here, I haven't actually put a URL there. I haven't even put in any kind of hard coding server, because that's the nature of Spring and Azure Spring Cloud, that as long as I have that config there, I can get the config. And all I had to do there in my startup is just inject the use config. I've got my, just add config server in my program.cs. Sorry, yes, add program config server. So that's my Planet Weather Provider, and I've deployed that to my cloud. Now, my Solar System Weather Provider is going to call all of those different Planet Weather Providers via a very similar mechanism. You can see here, I've got the weather forecast, and it's the Planet Weather Provider, and it's just going to go and get the Mercury, Venus, Mars, and Saturn. It's pretty simple. And then print out a logging and return back so I can get a JSON representation. And this kind of simulates one microservice talking to another microservice. I don't need to know the URL or the provider app, because that's actually injected into my calling microservice. It picks it up from Eureka, and then I can access all of the other microservices. And I can have up to, remember, in Azure Spring Cloud, 500 different services floating around there. So it's pretty important for me to be able to have that injection there, so I can just look it up and then call my services. So you deploy this with the .NET Publish. It creates your zip file, and then after that, you just deploy it with your CLR. So let me show you how that looks like. So you type in AZ Spring Cloud app deploy, and I've already done the deployment. Planet weather provider, runtime version, .NET Core 3.1. The main entry is the planet weather provider.dll, and then the artifact pathway, which is that zip file that we've actually zipped up there. The solar system or the planet provider, and I've already deployed it there into my microservices. So let's look at actually calling that service now. So I can go into my services, and now it will actually be already there. Let's go bigger. You can see there I've got Steeltoe rp.za, solar system, weather, Azure microservices, weather forecast. And this will call the planetary system and get Mercury very warm, Venus quite unpleasant, Mars very cool, Saturn a little bit sandy, and I've got a nice script in code spaces. Let's go pummel this with 200 different, where's my GitHub here, services there from code spaces. So let's go into code spaces. I want to show you, because we're going to activate my distributed tracing, and I want to do that from code spaces. One is because this code space sits in the same data center as the underlying servers, and two is I'm from South Africa and it's a little bit slow when I ran this here. I want to actually do that, and I'm going to call this about 200 times. And I have activated a public endpoint on my my solar system endpoint. I can actually activate a endpoint on my individual planets, but I haven't actually done that. And you can see they're preparing a code space, and I've actually cloned the full repo there, so I can and have been playing around and using this because it's so incredibly powerful and so incredibly useful as your code space. You can sign up for the public preview. It's really cool. And let's just wait for it to, and this is actually going to start to load my extensions. It's going to load the .NET and Java extensions for that, because each of the projects might actually use either. And I've got my little test.sh here, and test.sh is actually going to just call my in service there 200 times. So let's go test.sh. And I also recently got glasses, so forgive my typing. And it's going to call the planetary provider, and it's going to just return back all the weather for my services. So we'll leave that running there. Let's go back to our planetary. Now we've got some metrics. Now we can go back and we can see how this thing is actually going to be called. And we should see a spike of usage. And we want to go into our metrics. So this is my service, so my planetary weather provider, my solar system weather provider. And now I can go back into my metrics. We should see a spike of access here. We want to go into Azure Spring Cloud Steeltoe, and I want to do my process CPU. Should see, yeah, we've got a spike earlier. So it'll take a few seconds to get that, but I can also go into another metric here, which is my .NET, and I can see my current sessions. There we go, hosting current requests. And also I can go in and see my requests per second. There we go, boom. I had a huge spike then that I got. So you can go into your metrics. You can also go into each of the individual apps and see the individual apps by the standard metric dashboards. You can see there we've got a nice little spike, and that's the average request rate. the memory usage, the CPU usage is great, because remember, I'm running a big server here, so it's not really spiking the CPU usage. There aren't any exceptions here. So yeah, so a really big spike in the usage there. Now you can scale out. You can auto scale, so we're not going to cover that really in this session, but you can scale out. So I can go into my planetary weather provider and I can scale out either automatically or manually. So manually I can go to scale 2 items, remember up to 500 instances, or I can custom auto scale on a specific metric. You can see there, I've already kind of done that, current requests and also average requests, and I scale up in this regard. I scale up to 3 maximum, and when I'm not using it, then I scale down to 1 server. So we're going to leave that, but you can play around with that, the custom auto scale, incredible feature that you can start using right now. I've got my service bindings, my managed identity, and yeah, so that's that. But I want to show you the distributed tracing. Now we've been pummeling this now, and I can go into my logs. And I can also view the app service logs there. And just before I go into my distributed tracing, I want to see if I've got any errors. So I want to go, okay, logs, show me, let's go logs here, queries, filter, tables, let's go there, show the application logs there. So app logs, and it'll actually bring back, and I can see here that I don't have any errors. I've got, sorry, that actually went back. I want to make sure I don't run into errors, and then I'll show you on the distributed tracing, I really don't have any errors. Sorry, that went back there. Completely got me out of there. This is what happens with the magic mouse. I clicked on 2 things rather than 1, and it took me back. Let's go back into logs. Run there. Run. I want to make sure I don't have any errors. And yeah, there. So it says there, yeah, planetary weather provider default. And I can go into all of my logs there, and it says info. So that's great. So I shouldn't have any errors. And you can go into your logs there. So let's go look at the distributed tracing. I'm making for great time. So get your questions ready around Steeltoe, .NET Core, running on Azure Spring Cloud, and also Azure Spring Cloud, Java, microservices. And we've got our microservices, and this is the last 30 minutes. You can see there I hit Hello Spring, which is exactly what we tested. And then I've got my one instance here, 203 calls, which is exactly right, because I hit it twice or 3 times manually, and then I hit it another 200 times. And then I've also got the planetary solar system weather provider hitting the the planet weather provider. And I can go in there, and I can view my details, and I can investigate the performance. I want to see what the fastest service I got. So 5.91 seconds, which is great, which is really fast. And I can click on there and get examples for the dependencies, the actual services that it comes back with. So many examples here. Yeah, this is a wealth of knowledge, and our customers really like this service when we show them that. You can go into dependencies, and this is going out and roles, and you can also go view in logs. This is really nifty, and this is the distributed logging. Now I can have this side by side with my Java logging, so I can go into my Java logging and also do view the details there, investigate the performance, also great speeds there. And then I can also go into my performance monitoring, my dependencies, configure my Polar. I can even do polling. So I can configure my Polar, and this is using the Java and profile now. So if I go profile now, it'll actually session and profiles warming up and do a full application profiling on my microservice component. So I've showed you here log analytics, metrics, tracing, investigating performance. And I've showed you how to create your app, how to create your Azure Spring Cloud microservice, and I'm giving you some homework. So let's look at that homework again. Let's go back into the slides. Let me learn how to Mac again. No, you want to copy. I need to use presenter view. You're sharing the wrong screen. Wow, Teams, behave. Yes, screen 1. There we go. Presenter view. Yes, so the homework for today, go to https://cda.ms/1mh. Nice, easy example. You can just also go to the quick starts of Azure. You can start it in this. This will take you 7 minutes to do. A little bit longer to create the underlying Azure Spring Cloud. But once you get this and you start to play around with it, you'll really see what managed Kubernetes is about, because it's really running Kubernetes underneath there. This is a node. The Planet Weather provider is a node. It's a Kubernetes node. It's Solar System Weather is a node also. Eureka Server is actually an orchestrating registry running on Kubernetes. Config Server also a node. And you've got your database integration, which is really great. So the roadmap, we have so much invested in the service here. We've just had general availability 2 months ago for the Azure Java Spring Cloud, and we've just done the same for .NET Core with Steeltoe. So we're going to bring out PowerShell support, which is available. Then we're going to do security, the outgoing apps API, the tooling, the VS Code extension is coming soon, Azure DevOps pipeline, GitHub Actions, third-party integration. So really stay tuned for this, because there's such a vibrant ecosystem that we're doing with VMware, and it's going to be available in many regions. Currently, it's available in, you can see there, 1, 2, 3, 4, 5, 6, 7. We're going to make it available in a lot more regions coming up. So thank you so much. Here's some links, and Emma, over to you, and let's take some questions.
Thanks so much, Rory, for an excellent session. Yeah, I've been keeping an eye on the Q&A. We haven't had much come through yet, but we do.
They are so taken back by the fact that you can run Java and .NET on the same microservice platform that I think that I've just blown their mind.
Yeah, I'm keen to believe that as well. But we do have plenty of time left, so yeah, definitely, if you do have any questions at all, even any comments about this session or anything that has been demoed during the session, please do send them through. It'd be great to get some feedback about how you find this and what you're thinking. And as I mentioned, any questions too.
And yeah, reach out to me also about the homework, you know, the demo code, and tweet me up on @RoryPreddy around, you know, your feelings around the demo, around, you know, things that you discovered, questions that you had. We're really engaging. You know, the advocacy team here is here to really engage with the public and feedback to the product team. So we will take that feedback and feed it back to the product team and say, hey, listen, those developers, they loved your stuff, or those developers, they need a little bit more here or there and there. So we're here to actually make sure that your experience is a delight.
Absolutely. Thank you, Rory. As I mentioned as well, this session will be available to watch on demand. So you also have the opportunity to go back and re-watch what has been delivered today. So what I'll actually do now is post the YouTube link in the Q&A. It will take a couple of days for this session to go live, but once you have the link, you can always just bookmark that and go back into it towards the end of the week. So some feedback from Thomas has come through. Thank you, Thomas. No question. Thank you for a great session. Looking forward to playing with this.
Brilliant. Yeah, keep me posted. Hit me up on Twitter. My DMs are open, and I'm really looking to see how excited you guys. And let's all be friends. The .NET developers, the Java developers. It's a great time to be a developer and a cloud microservice developer on Azure Spring Cloud. Okay, great. I'm going to stop sharing. Yeah, so you can reach me on Twitter if you've got any questions after this. Thank you so much, Emma, for the time today. And as before, always an opportunity and a great experience to speak at the reactors. We've got some great sessions coming up. I'm speaking at the reactors on a few other great topics in November, and also reach out to the Java and Azure YouTube channel. We've got a lot of our sessions there, and yeah, Microsoft is completely committed to the Java ecosystem and running it on Azure, and there's so many exciting things. We've just released JBoss on Azure. We've got Steeltoe. There's so much to do.
Brilliant. Thank you so much, Rory. It's been great to have you delivering this session with us. And also thank you to everyone who has joined today. And I hope you enjoyed the session too, and really looking forward to seeing you all at the next session.
Thanks, everyone. Cheers.